Yeah, we increased the distance that we should be above the surface. And you can see he's kind of floating. Yeah, we're at 1109. So we'll walk into it and see if we can see anything that's going on here. I swear there's going to be something. The condition that we were failing earlier was that we were penetrating an object, and that was what was causing our problem. I didn't see that we had 2 calls there, so let's take that out. And sorry we're not doing much more interesting stuff than messing around with movement code and scratching our heads and writing down numbers and then rinse and repeat hour on end. But once we actually finish that, then we might do something interesting. But we can't move on until we solve our problems. Oh, come on, I totally saved this thing. Unreal. Oh. So let's see. What I want to do is step into the sweep movement object function and see what it's actually getting for its hits and all that. And if there's maybe a bug in there with some of our logic for the one-way platforms. So our response is reset. So let's see, we've got hits. We've got 7 hits. So it starts with this one. The distance is 9. And what's happening? So it's a blocking hit was false, and only blocking hit.start penetrating and ignore penetrating is true. Hit impact normal Z and hit start penetrating allowed zdiv, and what is the impact normal zdiv? Okay, so this has nothing to do with this stuff. This is our min normal z, our one-way z values. This is a bug in a different piece of code, probably. So what's happening is this is why it's the down key, which is screwing us up. Basically, what's going on is, so if you have like a one-way platform, right, and a one-way platform is like something you could like fall through. Maybe it's a bad name, but so if we're on a platform like this, and let's say there's another one-way platform that kind of goes down like this, and you're this character, and you will like just, if you're running this way, you'll just run right through the platform, no problem. If you're over here and you were running this way, you would actually run up this platform. But maybe you didn't want to run up that platform, so we have it so if you hold the down key while you're running, your guy will just run straight through the platform instead of running up it. And what's happening is basically to do that, we take the normal and we compare it to we take the z value of the normal that you're on, and if it's too great and you're holding the down key, then it's basically like, okay, don't change, what you're doing, just keep running on, the thing that's exactly the same. Hello, Kinto456. I'm not playing games at the moment. I'm working on games at the moment, and it looks like we found what's going on, at least close. So what is the one-way z value? It's 0.25, that's true. So what's going on is our surface z is 0, and our surface z should be 1. So where do we m surface z equals? So what's probably happening here is it's that we landed on the surface of this thing, but we weren't moving, so we actually skipped a whole bunch of code here, and we want this surface z to also be set somewhere else. So if we update flying, let's see, are we going to, this is flying locomotion, so we're in the air, so start in position, sweep object, internal set position, calculate velocity, overlap, I guess maybe what I should be doing here is I should be taking our collision.z here and doing our collision dot hit dot impact normal dot z. Alright, that might actually do it. So we'll snap ourselves to our ground, throw our collision stuff on there, and do all that. So that should fix it when we go from air to ground, so we have something. And the other one was, yeah, it was basically we were going from air to ground, and we weren't setting our surface Z to anything. Let's see, place. So place on ground is update snap to floor. So that should set our stuff. Alright, so maybe this will solve this. And the reason why it was the down key that was getting hit was the down key was changing the Z. And we did have an issue there where we were penetrating the object. So we did have like this worst of both worlds. We had two bugs and one was obscuring the other. And I was getting hung up on the first one. I was like, well, the first one should have fixed it. I was like, no, there's actually two problems going on here. Alright, so if I hold down the down key while running, I'll run straight through. If I don't, I run like that. Alright, well, let's make it so we're not hovering so much in the air anymore. And see if, so I'll reduce the penetration distance to 2 as opposed to 10 like it was there, so we should be 2 centimeters off the ground. And yeah, there are a few little weird things there, like where we run off those platforms, we're not actually like flying. There's stuff where we like run off and we're actually like, because we ran down this tiny little slope at the end of a thing here, like you've got it so if this is a platform that looks like this, your character actually runs like this, and then he immediately changes his velocity, so he's running down the slope, so when he runs off, he's actually like going super fast down, and it looks really, really weird. And what you expect, you know, is of course the character would run off here and just like, you know, continue in a parabolic arc or whatever the hell. That just has to do with sticking to the ground when we don't really want him to stick to the ground. That's really funny. So if you can see it, this platform is coming right through, right here, and Bitey's just not he's not small enough to get through. Just this tiny little bump on the head. No. And he falls to infinity. Alright, let's take another look at running all the way down here. Yeah, and the reason the camera's kind of freaking out is because all these things are labeled as terrain, which the camera is actually, it's casting this thing out to try to use stuff, and it's it does things. Like all these things should actually be environment pieces as opposed to terrain pieces, because the terrain should stop the camera, and this level was not updated since the camera was changed. So let's just run up the long wall. Alright, we can run up the long wall. Can we run down the long wall? And it looks like we can run down the long wall as well. Okay, jump, do all that. Let's check this guy out. Go up the long ramp. Down the long ramp. The RNG of getting dropped. So you basically made a progress quest game? I mean, that's basically like just a spectator sport there, so lots of stuff like that I think has been successful in the past. And I do like that we've got, you know, the new animations here for Bitey, so he looks cool, and he's got all this lighting stuff on him. Like the camera is just freaking out here. It's like, I don't know what to do. Alright, so it looks like the movement is working as it should be. So I'm just messing around in case I see something wrong that's happening. I mean, there are things that are not correct, but it's more of like we're looking to get stuck on something. We're looking to have something really awful happen. Because we're going to change a lot of how everything works, like how we hit our head on stuff and how that changes the landable stuff, the slopes. Those things are going to change. How we like run off of things, we're going to be fixing that. That's more of like, I want stuff like getting stuck, you know, the platform traverse, like getting hitches in the movement. So like if Bitey gets stuck on something like one of these little seams here, you know, like we get odd hitching on those. That's what we're looking for to fix. No, the camera is messed up right now because all of these things are classified as terrain when they should be classified as environment pieces. And the only things that should be terrain are like things that you can't get through. So like this should be environment and environment, but this should be terrain. And that way, like, the camera won't go outside of the bounds into, no man's land, because there's nothing out there. But right now, since these are terrain pieces, the camera doesn't want to go past it, and so it'll get stuck. So when you jump up, the camera will kind of wing out there a little bit, and it looks real odd, which is what you want. It's just you don't want to have terrain where there's not supposed to be. Alright, so I am confident that that's actually working as I want it to. So, not bad. Alright, so let's go ahead and remove some debugging stuff. Kinda makes the camera seem alive? I don't know. When you're actually manning the controls, it's more just awful than alive. Thank you for following, Gilboard. We'll see if we can actually get to something interesting. So let's start chucking all this debug stuff out of the way because we don't need it anymore. Alright, so what the hell was this code? It was like, if we're now flying. Alright, we can kind of get rid of some code here. So I'm looking at this. Okay, so if we swept our movement object and we didn't collide with anything, we're moving, and then we're going to calculate our floor stick, and if we don't snap to the floor, what we're doing is what is this? Cached object extents.y. Yeah, so this looks like it's looking back. This was when we were running along an edge and then we started flying. It was taking the wrong impact normal. So I need to comment this code. All right. This code here calculates the normal you were on before you left the platform to make it so you more smoothly run off things. So we're basically grabbing the extents of your dude in the y direction, we're adding a small constant to it, and then getting the normal at that location, rotating our vector based on that. Okay. And then we're actually moving ourselves as well in like another direction, so there's that. We probably have to do that for everything, so we might have to come back and do that. Anyway, let's at least throw that in our constants. Let's see if we got any other debugging code that's needing to get removed. Doesn't look like it. Alright, let's just build that and make sure it's still running as we want. And I'll probably have to take a couple minutes here in a little bit, because I've been going for how long? About 3.5 hours, so I need to refill my water bottle, things like that. Keep myself from going absolutely insane. So, and in regular fashion, I went and changed some global variables for my program, and we have to go recompile stuff. But it's not going to take too long. There we go. So after we remove their debugging stuff, we just do a sanity check here, make sure that everything's still working as we thought, just because, you know, I'm usually just trying to be thorough. If I'm gonna leave something alone, just one more look to make sure I didn't accidentally delete all the things. Let's go back to the other level. What is that? It's just, Alright, cool. So that is all working. I'm gonna set the level back to the camera test level. I'll save that. I'll exit. And since we've actually gotten some progress on fixing stuff, I'm just going to go ahead and check in the work that we've done to give us a good spot, and then I'm going to take a couple minutes here. Fixed movement issues with getting stuck and mantling. So the next thing we'll be working on is we need to figure out how we actually are going to move this character. So we've got a few things to think about. So I'm going to be right back. Just like a minute or two. So I will see you in a bit. Alright, well, let's figure out how we kind of want this character to work. And I'm gonna need to run upstairs. I'm cooking some food that'll I can just kind of eat while I'm thinking about how to design this thing. So we've got the movement controller right now, and how it operates is so I'll pop it open. We just call these functions right now, which is like we have some movement data, and the movement data defines what we can do. And basically, we set a, let's see, it's in gameplay, player logic. We've got a player logic blueprint which runs on our dude. And really all we're doing is we're calling set wanted velocity in direction vector. And then we call just like, we just call jump when we jump. So the only thing that we're actually changing is like set wanted velocity in direction vector, and that's it. That's all we're doing. That's how we're moving right now. Literally is just saying like, well, the player press left and just go to the left. And so we've got two things right now. We have our wanted velocity vector, and we have jump. So what we want this character to do, we want this character to kind of, it needs to, if you hold to the right, you know, he should like start running, and then he should start running faster, and then based on his speed, he kind of, I was thinking we would kind of have, character would have different gears. There's a speed, so if you keep holding it, like he runs, and then once he's running fast enough, he starts, you know, breaks into a jog, and you know, first he's walking, and then he's running, and all that, and the acceleration kind of changes. Like instead of accelerating smoothly like we have now, it's more of the acceleration is based on what kind of movement the character has, so which gear they are in. So we're actually like dynamically swapping out our movement data. And our movement data right now is controlled by these like blueprints, which basically control things like our velocity for movement, our jump velocity, passive and active velocity changes, how much control we have in the air, stuff like that. So we're going to want to change all of that sort of stuff. Anyway, I need to go check this thing so I don't burn my food. Yeah. So, the character is going to have different gears of speed, so how are we going to accomplish this? Like, so there's different gears of speed. We change our acceleration, velocity, all that on the fly. We change how we interact with physics, like if we stick to the ground as well, etc. So like if our character is running like super fast, like it may be that, you know, we would just fly right off something, and maybe that's velocity dependent or not. Oh, well, that's a good question, Kinto456. So basically how we run things around here for scheduling is we kind of give ourselves, I'll just throw like some stuff here. This is kind of like what I do for my weekly sprints, is I'll have a set like list of tasks that I want to get through and all that. And what I basically do is I mark off like the stuff that I do, and I've got like an amount of work that I want to get done, and it's basically I try to keep my velocity at like an average of like just under 2 per day or so. It's kind of what I do. So we have tasks, we assign story points to them, and then we just see how much we can get done and stuff like that. And then we have a much longer term schedule, and so we don't have like set hours about like, oh, I'm gonna work for 4 hours today or something like that. It's basically work when you feel like working, get done as much as you can when you feel like working, and then just track how fast you're getting stuff done at the end of the week, and use that to figure out how much you can probably do next week. And then you build the schedule around that. So yeah, that's pretty much how I've always run things. Even when I was at Electronic Arts and Amazon and everything, we didn't care if somebody was working all the time or anything like that. All we cared was that the tasks get done at the end of the week, and that we maintain a consistent amount of stuff getting done. So, and then be honest about, how long things take and all that. So if somebody really doesn't feel like doing something, we could deal with that. Being self-employed, though, it's more of I just try to keep working when I feel like working, and I try to make sure I'm not working when I don't feel like working. And I haven't really had any real problems with that, keeping a schedule and stuff like that. It's been pretty good. And preventing burnout really it's about other decisions in your life, to be honest. Like, if you're burning yourself out, it really depends on everything else that's going on. Like, if you are ignoring other things in your life, you're not getting enough sleep, you're not doing these other things, that's just going to keep messing with you. So preventing burnout is not always as much to do with actually not working as much. It has to do with making it so that you can actually work, as opposed to having to work when you're exhausted or something else. So things like, even simple things such as making sure you have a lawnmower that works so you can mow the lawn. without taking 2 million years to do it. Things like making sure you have the right food in your house, so you're actually able to like cook food and eat it in a timely fashion. And then, you know, actually making a schedule and knowing where, you know, things are on the schedule can allow you to, you know, relax and make decisions. So that also helps with burnout, is just knowing if you're actually on track or not. Alright, so we're going to have to change how we interact with physics. If we stick to the ground as well, things like that. We're going to have different movement flags, like if we can run over water, etc. Things like that. And we're going to want the character to, we're going to want to transition to the appropriate gear or movement mode based on velocity, I think. Yeah, we definitely put deadlines. That's why we write all of our stuff down, and we have deadlines. But the idea for the deadlines is to be honest with the deadlines, not to crunch for the deadline. So if you miss the deadline, miss the deadline. Don't try to miss the deadline. But if you're not going to make the deadline, just don't make the deadline. And, you know, make sure to spend some time talking about why you missed the deadline. But don't kill yourself to make the deadline, because there's a lot more work that has to be done. If you kill yourself for one deadline, the next one's already slipping. So we do like weekly sprints, which is basically every week we figure out what we're going to do for the next week, and then we talk about like what went right and what went wrong. And then we have much longer like milestones, which are, you know, like 8 weeks, something like that. And we take a longer period of time there, and that's where you actually like change the schedule. Alright, so we need different gears, which are based on our movement modes, based on velocity. So when would we transition to a different gear? So like, if we were in the air and we landed, what movement mode do we enter? I guess this would be like from in the air into, you know, running and stuff like that. So I guess we would, you know, just land, and since you're going at a certain speed, you do something, I guess velocity based. And what kind of velocity? Is it like downward velocity? So like if you landed on a slope that was near vertical or something, like you jump and you land, and you were like moving really quick, and you jump, your guy was super dashing, but then he's like on a slope that he can't really run up very well. He's actually going to slow down. How is he going to slow down? Like, is it velocity based? Is it component velocity? So instead of having our velocity be for our movement gears or whatever for entering, maybe we just have our Y movement velocity, so our Y axis is like this. And so if you're like moving very quickly to the left and right, that actually determines how fast you go. Or is it based on the surface normal or something else? Yeah, it might be easier just to do the horizontal velocity. Alright, so how can we accomplish different movement types? I mean, we could data drive the movement, have different modes and data drive the whole thing. Another thing is we could have blueprints for each mode, which flip settings in data for the movement controller. So we could have like a state machine kind of thing for our movement time. I kind of like the idea of a blueprint node driven state machine for the movement controller. Basically where you'd have like a running blueprint with a tick function and like an on enter and an on leave and all that, and basically like on enter you would like change your velocity and set all that stuff, and then you could also control your animation and your transitions inside of that. We'd have to have things that come in like if you're on the ground or not, would be certain things that would come in and you get notified, then you'd be like, okay, well we should transition to the in-air movement state. And if we define that all in blueprints, it'll probably be easier to maintain because we'll have actually specific logic to deal with stuff. I mean, we have to go set up a whole system for that in order to make it easy to use, but kind of like basically what happened is all the movement code would happen inside of C++, and you're just like changing all these different flags and calling different things like jump or whatever. Yeah, rotating a character to like snap them to the actual surface slope, right? Like if we have a slope like this, we want to rotate the character so he's like that. Like it's not going to work, right? In 2D, like, you know, Bitey's head would be over here. You know, and those are his legs or whatever, and those are his arms. That's why Adam's the artist. You know, it just looked like crap. He's like standing on a slope that's not good. Like you'd want him to stand, you know, with like one leg here and one leg down here, you know, perfectly vertical and whatever. But you know, that's not gonna work. So no, the rotation stuff, I don't think it's gonna happen. Like you have to change everything. So you're saying that there are some states where we'd actually want the animation, if that's like his slide and, you know, his head is here and his feet are here and he's sliding down a slope. You know, if we lock that to the slope, well, the issue is going to come in, like, his collision box needs to not change for this to happen, and, like, it's just, we're pretty much screwed. Like, the collision box has to change completely for this to work, and, you know, if we run into a wall or something, you know, we're just going to have a really bad time. Well, it depends. We could do a few things, but I mean, we could rotate animations and not rotate collision. At least not rotate the physics movement collision. You know, we could rotate the hit collision, no problem. But I think that's going to be something later. Like, that would be like movement version 3, to be honest. Because that's just changing, like, we're taking the data of an already moving character